Hey everybody, just want to give you a quick heads up, a little help video for the Ohms Law Lab that was posted yesterday, Thursday, April 23rd. So today you've got a little bit more time today to finish this up. It's not due technically until Monday, but again, get it done when you get it done. This you are going to submit in the assignment, so make sure that you click in here and you upload your file, whether you take pictures of it or if you did it as a Word document, upload those things when you're finished for me, please. So one thing that's a little confusing, and I put a link here, there's a slightly different simulation that you should go to get it to look exactly like what the lab is written up as, and I'll explain here if I click out of here for a second. This PHET website has two different circuit simulators, and I've been using this one with you guys. It turns out that this one is also a nice one. It's a little bit simpler, but so if we go back to the lab, you click on the sim here, and that will lead you to the correct simulation. And just walk you through what that looks like. So it jumps you over here, and it says Circuit Construction Kit DC. And as soon as that loads up, you got two options. You want to click on the lab option. And to save us time, I've already constructed the lab or the light bulb circuit that we're supposed to. All right. And the reason that this is so nice, if I just connect this up and hopefully I can move my picture out of the way, instead of having to put an ammeter in here, which requires me to break the connection, attach it here, and then do that. I can use a nice little meter that they have, and hopefully this doesn't jack up everything too bad. Let me get my light bulb back in place. So they have a different current meter that literally allows you to just drag this over top of the simulation, and it's just going to magically give you a current measurement. Now, the other thing that I wanted to highlight is we've been talking about conventional current, which goes from the positive end of the battery to the negative end. So that we're consistent with what we've been talking about, we'd probably want to have this conventional current flowing. All right, so at this point, I think I've given you all the things that might have been important. You come in and you create one of these little short circuit wires. And so if I look at the current right now is 0.15, and I go in here, and now it's a slightly different value. And you'll notice that there is not much at all going on in this first filament because we've given the electricity, in essence, two options. The electricity could go through the filament, which if you remember is a very, very tiny coiled wire, or it could just go through this wire. And if you think about what we were talking about with resistance in the class time video from yesterday, Thursday, April 23rd, electricity sometimes encounters resistance. And just like humans, if I encounter a path and there's a high resistance and a low resistance, most of the people are going to take the low resistance path. So the electricity is like, nah, I'm not going this route because there's way too much resistance up in here. And we're just going to bypass you. So the electricity now has a different route. And you notice that the current changed. So I think that's enough to get you going there with the lab. Stop by during office hours if you're having any trouble. And hopefully this helps. Everybody be well, and I'll see you again online soon. Bye-bye.